everyone, it's Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating arbitrary function f from z equal to xy plus f of x square plus y square plus z square. So we are asked to form a partial differential equation by eliminating this f from this equation. Let's see. Given z equal to xy plus f of x square plus y square plus z square, consider as equation number 1, right? Now let's partially differentiate it with respect to x. Just apply dou by dou x on both sides of the equation, okay? Partially differentiating 1. Partially differentiating 1 with respect to x. Just apply dou by dou x on both sides of 1. Since we are partially differentiating with respect to x, so we'll treat y as constant here. And also we know that z is a dependent variable where x and y are independent variables, right? This gives us dou z by dou x equal to dou by dou x of first term plus dou by dou x of second term, right? Fine. Since we have a notation dou z by dou x equal to p, let's replace dou z by dou x by p. We'll get p equal to, here y is treated as constant, right? So we'll write this term as y into dou by dou x of x, okay, plus partial derivative of f of x square plus y square plus z square with respect to x is f dash of x square plus y square plus z square into partial derivative, that is inner derivative, okay, fine. This gives us p equal to y into partial derivative of x with respect to x is 1 plus f dash of x square plus y square plus z square into partial derivative of first term plus partial derivative of second term plus partial derivative of third term, everything with respect to x, which gives us p equal to y into 1y plus f dash of x square plus y square plus z square into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0 plus partial derivative of z square with respect to x is 2z. I mean 2z into dou z by dou x. 2z into dou z by dou x. Right? Fine. This gives us p equal to y plus f dash of x square plus y square plus z square into 2x plus 2z into, just replace it by p, since dou z by dou x equal to p. This gives us p equal to y plus f dash of x square plus y square plus z square into, take 2 common from these two terms, we'll get 2 times x plus zp, consider as equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Okay, just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us dou z by dou y equal to dou by dou y of first term plus dou by dou y of second term. Since we have a notation dou z by dou y equal to q. Let's replace dou z by dou y by q. We'll get q equal to, here treat x as constant, so we can write it as x into dou by dou y of y plus partial derivative of f of x square plus y square plus z square with respect to y is f dash of x square plus y square plus z square into inner derivative, that is dou by dou y of x square plus y square plus z square. This gives us q equal to x into partial derivative of y with respect to y is 1 plus f dash of x square plus y square plus z square into partial derivative of first term plus partial derivative of second term plus partial derivative of third term. This gives us q equal to x into 1x plus f dash of x square plus y square plus z square into partial derivative of constant with respect to y is 0 plus partial derivative of y square with respect to y is 2y plus partial derivative of z square with respect to y is 2z into dou z by dou y. Now just replace this dou z by dou y by q. We'll get q equal to x plus f dash of x square plus y square plus z square into 2y plus 2z into q. Just take 2 common from these two terms in the next step. We'll get q equal to x plus f dash of x square plus y square plus z square into 2 times y plus zq. Consider as equation number 3. Now observe equation 2 and equation 3. In equation 2 we have p minus y p equal to y plus f dash of x square plus y square plus z square into 2 into x 2 times x plus zp, right? Also we can write this equation as, just bring this y to LHS so that you'll get p minus y equal to f dash of x square plus y square plus z square into 2 times x plus zp, or you can just bring this to here, okay? And also you can write equation 3 as q, just bring this x to LHS, you'll get q minus x, it's q minus x, okay? Q minus x equal to f dash of x square plus y square plus z square into 2 into y plus zq. Now from these two equations we can just eliminate f dash of x square plus y square plus z square with the help of this equation by this equation. If you consider it as some equation number A and this as some equation number B, using A by B, we'll get LHS of A by LHS of B equal to RHS of A by RHS of B. Where 2 gets cancelled and f dash of x square plus y square plus z square gets cancelled, and this gives us p minus y by q minus x equal to x plus zp by y plus z. I think it's q zq, right? Now make a cross multiplication and simplify it. You get p minus y into y plus zq equal to x plus zp into q minus x. You need to simplify it now, okay? Well, this gives us py plus zpq minus y square minus into plus minus qiz equal to xq or qx minus x into x square, x into x is x square, right? Plus pqz plus into minus minus zp into x, pxz. Fine. Now you see you have pqz in LHS and in the RHS. Let's cancel it out. and fine. Now let's take this y square to RHS and bring this two terms to LHS. Then you'll get py minus qx minus qyz plus pxz equal to y square minus x square, right? Fine. Now let's take p common from these two terms and q common from these two terms. We'll get p times y plus xz minus q times, just take minus q common from these two terms, okay? We'll get minus q times x plus yz equal to y square minus x square, which is the required partial differential equation. Okay, we'll just write the terms involving p and q in the LHS and the terms which does not involve p, q in the RHS, right? Therefore, p times y plus xz minus q times x plus yz equal to y square minus x square is the required partial differential equation. Which completes the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.